So next, we have Dr. Leonardo Alcayhuaman, who is president and founder of the American Society of Civil Engineers, Region Peru, professor in the Civil Engineering program at Ricardo Palma University. His research has focused on the engineering of the Inka Empire. Leonardo.
Buenas tardes con todos. En primer lugar, quiero expresar mi profundo agradecimiento al doctor
Ramiro Matos, who was the organizer of this great event about Inka engineering works. Likewise, I would like to thank his whole team for the great effort they've made so that today Peru is celebrating festivities, especially Cusco. I am from Cusco. On the 24th of June, I was very happy and emotional. I felt like crying, but I said, Inka people don't cry. 4 years ago, Dr. Ramiro and Dr. Jose talked about this project, and I didn't fully understand it. It was something too big, it was very large, and this is where we see the great capacity of Dr. Ramiro Matos and his team to organize events such as this one. Today, I am feeling very proud of the fact that Dr. Matos was appointed unanimously by the University Council of my university. Professor Emeritus of our university, and we will have the honor to grant him this in Peru. Today, I will talk about this, the monumental achievements of Capagnan. Researchers, presenters have shared their knowledge around this integrating work in Latin America. We have a lesson here. Science and technology, or in a country such as the United States, we have the science and technology of the Incas through this great work, which today we would call road engineering. The presenters that spoke before me shared a great deal of information. That's why I would like to apologize to the audience. I won't speak too much about it because you've heard a lot about it already. You can see the road in the picture. It's a road, but it's also called trail. This is a great engineering work. And in this case, it's in Tipon, the ruins of Tipon. I will talk about this later on. If we analyze the present and the past, we can see the last achievement in terms of building engineering. The one on the left is Dubai, but the Incas also had great achievements. You can see that work in stone. It has nothing to envy to the one on the left. That was the quality of the Inca engineering in stone. Dr. Alvarez was talking about the founder of the Inka Empire, the Manco Cápac Inca. When we're talking about engineering today, building engineering, civil engineering, what we have to identify is the soil and much weight can the soil bear? Our Manco Cápac Inca, based on history, said the following, and that's why the island of the sun. He came from the island of the sun, and he said, wherever I put my golden baton, that's where I will found the new city, and that's what happens in Cusco. And that is why this great empire started there. The first test of the capacity of the soil, of the terrain to bear weight was done there. That's the first thing we have to do when we're going to build something. We need to understand how much weight the soil, the terrain can bear. And that is why civil engineers consider this Inca person the main person in terms of soil engineering. So when we talk about building engineering, road engineering, hydraulic engineering, textile engineering, Incas actually known all the different engineering fields. And here in this picture we see part of the Inka Road. In this other picture we see a building. Please look at this building here. It's made of stone. You see this wall, and let me ask you something. Is this wall really vertical? And then other proof of ingenuity is the Moray works, and also the Tiron works, which is an open channel. Can you imagine what happens from one level to another when water goes down? How did they manage the energy of water in this topography, in this work of art? We could also analyze Ollantaytango, the gateway of the sun. Here there is a line of stones here, and on the other side, right on the gateway to the shrine of the sun. Is this a coincidence that we can find those stones in a line? Well, what we found is the higher we are, the stronger the wind draft is, and that was a problem that had to be solved. And as we will see later on, those things will serve a purpose. The Incas always had an objective in mind and didn't leave any details out. The Moray ruins are concentric circles, and they are very close to a lake, the Waipo Lake. And there must be a channel or waterway to bring water from the lake to the ruins of Moray. I've been right here, and I could appreciate the little channels or canals that are very similar to the ruins of Tipon. And what would be the goal of this? There are speculations in this regard. There are many different hypotheses, but maybe it was a great laboratory to study the response of different plants based on altitude and temperature.
So we've said that with this configuration, we have some of the engineering feats that we know about today. If we look at this slide, we'll see once again the gateway to the sun. You can see some of the protuberances there that we saw a little while ago. There's a whole work of art there of stone, and perfectly placed. As we had seen previously in the other slide when we were looking at this Inca residency, which is the Calle Loreto Street near the Huacaypacha Plaza. So how is this type of wall made? Today we are speculating that it's so solid that not a single needle could go through. The Incas have polished stone blocks, of course, and in spite of this great work of polishing each stone, making them very shiny and smooth, they still did not make them perfectly smooth. So how were they able to do this? They used, and we see the evidence now, what now civil engineers call mortar, which is the union of cement and water. And this helps to bind together other construction elements. And the Incas did this in order to make sure that the surface for joining with another subject would be perfectly straight. They had a mud of a certain kind with water, and to make sure that that was totally pure, they produced what today we call dry soldering, and that's very difficult to do. Obviously, when you have two materials that are totally stuck together, you can't take them apart again, and that's what the Incas were able to do, especially in constructions of the residence of the Inca himself. So here you see some of those examples. But another problem, especially in the Temple of the Sun, is that these stones were carved so well to be open up the channels of union, and those channels made it possible to be joined perfectly with other blocks. This was a technology that they were able to use, and in addition to that, we have seen this kind of wall here. Now these holes in these that appear in some of the walls of the Incas, especially in the residences of the Inca, have a certain goal. They are drainage systems. And that exists in all of the ruins, in all of the Inca edifications in Sacsayhuaman, for example. You have this kind of drainage. But those of us who don't understand about conservation, these kinds of channels were destroyed and the rocks were rent asunder. So we have a great challenge. And so through our lack of understanding, we have destroyed some of these things, which are the engineering of the Inca. Now, this construction here has the same quality as the constructions in Cusco. And see how the distribution and the light through windows is handled here. These kinds of symmetries and alignments, unlike the wall that we just saw of the Loreto Street, you can see that this wall is perfectly vertical. And so that's why I was asking, why in most stone walls, is there a slight slope, not more than 5 degrees? Now we do have 2 constructions in the highlands and in the coast that used clay and adobe. Another important characteristic of the Incas is that they have had a great deal of ability to do stone work, to work with clay and mud and ceramics. And we also have this Inka Road that left from Cusco and went to every place. And here, very close to Lima, near Cañete, there's a little valley called Lunahuaná. And there you have what's called the House of the Inca. the Incahuasi in this case. And this is a replica, an exact replica of Cusco. But who did this? It is said, and some of the other presenters have mentioned this, that there are three important Incas, Manco Cápac, Pachacute, and Tupac Yupanc, the Inca Tupac Yupanc. Now, Pachacute was known as being a builder and was trying to improve the Inca Empire through building. And it said that Tupac Yupanqui was a warrior and a conquistador. Now, Tupac Yupanqui probably passed through this zone and probably conquered the Huayro culture. And the Huayros were a group, a society that had been very besieged by war. But it probably took 4 to 10 years for the Incas to conquer them. They put up a great big fight. The particularity that we see in this one are these columns. Circular sections here, the columns that I'm showing you. 64 circular columns have been found. Obviously, in most Inca edifications, we have not seen this type of circular columns. This is a mix of clay and stone. But if we leave the valley of Huahuaná from the coast and we go to the highlands of Peru, perhaps many of you have been to Cusco. You've been to the ruins of Chavin, and there we find some columns like this one that are also circular. Today, construction engineers use them for what? They use them because they have greater capacity to carry weight. But the Incas already knew how to do this. So we wonder why they didn't use these columns in the other buildings. And what one thinks of is also that if you see large quantities of these kinds of circular columns in the ruins in Mexico. I think there's a doctor here from Mexico, so I think it's in Cancun, where there's a huge line of these types of circular columns, which are also in a state of abandon. And unfortunately, we only have in Lunahuaná, and the last time I visited there were only about 6 or 7 of the columns left from the 64. Since we don't have the culture of conservation, destruction continues to occur. But now we need to be very conscious, and we need to generate a new culture of conservation and management of these sites. Here we see this stonework. This is the Incahuasi of Lunahuaná. And we see this type of construction, stone, adobe, or clay. But the most important thing, and it's fascinating, is the management of the distribution, of the ventilation, and the light. Let's look at the next scenario. What are the great challenges that we have now? For Peru, first of all, it's in a seismic zone, and that's always been true for Peru. And in the mountain areas, you have the problem of the huaicos. We have the Niño phenomenon. And so the Andean engineers already knew how to deal with that, as well as drought. A short time ago, a professor from the highlands was showing us how the frosts, how the Incas knew how to use frost, and they made chuño during that time. And as the doctor said, this food can be conserved for as long as a year. The Incas observed nature closely and learned from nature. In these configurations, they said, how do you mitigate seismic motion? How do you mitigate earthquakes? And so that's why when I began the presentation, I emphasize that these are works that have been usable and useful for more than 500 years. And the amount of weight they have on top of them is greater every day. So some of the terraces are falling, but we do have some initiatives of Dr. Ramiro Matos in that area to preserve them. There's a group of researchers that are trying to save the drainage channels. But how did the Incas deal with seismic movement? It's a tremendous thing. In the cases of Pachacamac, there are vestiges of where you look under this level of the surface, you see there's a cemented area alongside of the wall. And you have sort of curved areas, and they dissipate the energy of the earthquake. And that's why these structures have not fallen. So they learn to mitigate and to manage these natural phenomena. Now we were saying, okay, these walls aren't perfectly vertical. They're slightly inclined, just very slightly. We could test it. It's probably not more than 3 degrees. And for those of us who have an idea of what a simple pendulum is, if you oscillate it 1 to 2 to 3 degrees, it will continue with that same vibration. And so there was a hypothesis is that that slope was made on purpose. Here in the diagram, for example, if it was a perfectly vertical wall, it would have this configuration. That's how the weight would be distributed. But since it's slightly sloped, then you have 2 components, and there's a restoring pressure that mitigates the pressure of the weight on top. So that means that there's nothing wrong with these walls. They're done exactly as they were supposed to have been done. That was the great ingenuity that they had. And this is part of their engineering. In these slides, we can see the kinds of materials they've used as well. There's the biggest star that Dr. Ramiro Matos is looking at is the Inka Road. As Dr. Alvarez said. And it gives us a great deal of satisfaction to know that there's a group of Latin Americans who have come together to study with the Inka Road with so much passion, from Colombia all the way down to Argentina and Chile. And here we see those researchers today, and we need to congratulate them. But we also have talked about integration in this symposium. This is a group for research, and we need to work in an integrated form so that we can be a group of research. And we need to teach about the Inka Road to people who are going to be conserving this road, even though these are poor people. But why are they poor? They are wise people. They have many riches and a great deal of wealth in many ways, but we have isolated them. And now what we need to do is to do a complementary work of incorporating and including these people who have so much knowledge. When we look at a modern road today, and you have over here the Inka Road, but you see that it's got some gullies on the side, gutters. And I might dare to say sometimes when I talk to engineers today, I say, you know what, you're missing out on a whole group of models of engineering. Because I think many of them would be inspired by the design for roads that the Incas had. Well, I've talked a lot about this, but from the point of geometric design, I want to insist that the beginning of design of the Inka roads has always been, and as we've seen in every conference, that there's a tracing out of the road in a straight line. Now, obviously, there may be variations in the width up to about 15 to 20 meters at some point. Now, yesterday, my friend Clifford explained from an engineering point of view that all of this work of Capagnan includes all of the topics of road engineering today. How to deal with drainage in various zones. And he showed some drainage channels that were perpendicular to the... And all of this is calculated. In times of rain, you didn't have too much erosion, and that's genius. They've also mentioned in special works that always throughout the road you have channels. And all of those channels have a constant stream, and we can see this. We've also mentioned that in different areas we've had containing walls, and here you can see that you have very difficult landscape, and so you have to have containing walls. Here you've got some plants that are helping to control erosion, and they always took advantage of the local materials and labor. They didn't have the need to transport materials. There you have the drainage channels. I think our time is getting away from us here. I'm going to move on. This is what I wanted to mention. This is part of the road, but there are stone staircases. And what we most notice about this are these steps and counter steps there that are also have a slight slope. If you look very closely at the stones there, you see a certain kind of cut with a certain kind of slope. And here you can see it very clearly. So that when you go up, it helps to push you up. And if you go down, it helps to slow you down a little bit. So you really need to look at that closely and to appreciate that characteristic about these stones. It's in difficult areas and swampy areas. They've always had straight roads and straight lines, no matter what the terrain. Another thing that's very important that I want to look at are the hydraulic works. The hydraulic complex in Tipon is considered part of the Inka Road as well. But we're going to look very quickly at the use of technology here. This is 21 kilometers to the east of Cusco. And these are the channels of Cumbemayo in Cajamarca. And this was 1,000 years BC. And look at these channels in Tipon. How could they make sure that the water would fall perfectly over the vertical wall from the top to down? The design of the channels today is a uniform flow. And you have to use certain formulas and appropriate software. But the Andean engineers had a way to dissipate the energy of the water. And the way they did this is here. Once again, you see that the way that they dissipated is this. They made contractions and expansions. That you can see some of that here in angles and in that part from one line to the next, in such a way that the water would be able to go very easily over the vertical channel. But they also used what's called buffer tanks. Here we do have a buffer tank, and it's perfectly carved. There you have the 1 meter by 1 meter buffer tank, and it's calculated 1 meter by 1 meter. It's genius. These are energy dissipators, so that the flow would fall with the same velocity and from a high velocity it would go to a low velocity flow. And here we can see another beautiful example of the channels of Tipon. And you can see how they are controlling the biochemical demand. We'll move here to Cumbemayo. As I was saying, it would seem that the Inca engineers had visited Cajamarca, though in Cajamarca, the last Inca died there. And here you see the dissipators, energy dissipators in the straight line in the channels of Cumbemayo. And it wasn't just about managing the speed. They also set macro sort of wrinkles or uneven spaces every certain distance along the walls. And this made the velocity of the water flowing from up to down to be a little bit slower, so that you'd have a uniform flow. Now, it was probable that the Andean engineers of the Incas did use this technology. These macro regulators and they were used in various places to in some places to straighten and regularize the velocity of air movement. In this case, it's for water movement. And here, we've made some measurements of the channel, and we've been able to apply the software necessary. And you can see very easily how you have the water on top there flows downward, and then you have a uniform flow. And then you see how it moves from high energy to low uniform energy. Same thing here in terms of the variation. So this is hydraulic engineering software. And what I'm trying to say that this Tipon is a great laboratory of engineering. Once again, you can see the results here of the calculation through the software. Speeds that varied, and the flow amount is 5.6, so it's a turbulent flow. The speed is very high, And when it gets down to this lower part, the velocity goes down to 1.5. There you have the hydraulic model of the stone of Desahuite. And all of this works very well. And so now we have come to some conclusions. Civil engineering of the Incas continues to be high-quality technology. 2, the buildings and edifications show knowledge of mathematics, natural sciences, and mechanics of flow, among other things. Andean engineering has been very respectful of the environment. They worshipped Mama Pacha. These are great models of optimum and efficient engineering at low cost. This is a necessary message for today. We need to have groups of researchers, and here we've had presentations from the architectural point of view that Alejandro and Ricardo made, but we need to have a vision, point of view of civil engineering. So we should do a topographical map and begin a technical file of the Inka roads, because at some point, how would we rebuild them? We need to do a good study of the drainage system in Sacsayhuaman. It's very complex, it's difficult. So the research team, led by Richard Misak, is helping us to look at this type of issue. And so we need more engineers to be able to get together with all of the knowledge and information that we've heard over the last few days so that we can make this work a complete one. Thank you very much, Dr. Ramiro Matos, and congratulations for being a great teacher of Inka engineering. Thank you.